This is lesson 3.3, the multiplication property of equality in pre-algebra. And in this lesson we're going to again solve equations. And in the last one we solved equations if there were numbers added or subtracted to a variable, a letter. And in this lesson we're going to look at what to do when we have numbers multiplied by a letter. So first of all, the multiplication property of equality says that if we have one number and it equals itself, so let's say 6 equals 6, then if we multiply any number times 6 and we do it to both sides, it's still a true statement. So just like in the last lesson, when you could add or subtract any number, as long as you did it to both sides, it didn't change whether that the left and right side of the equation was equal or not. Multiplication is the same thing. We can multiply any number times one side as long as we multiply the same number times the other side. In fact, we can even multiply letters, and we'll get to that later. So what we're going to do is we're going to learn again. Now I'll just do a real quick review here. If you remember when we had x plus 3 equals 12, isolated the x by subtracting 3 from both sides, and that gave us x equals 9. Well, the same is going to be true to a certain degree with multiplication. Notice, in our addition and subtraction, when we had a plus 3, in order to get rid of it, we did the opposite. We subtracted it. When we have a times, so 3x equals 12, again, we're trying to isolate the x. We're trying to get it by itself. So we're trying to get rid of that 3. Well, the only way we can get rid of the 3 is to divide both sides of the equation by 3. So just like we did up here, in order to get rid of the plus 3, we subtracted 3 from both sides. In multiplication, in order to get rid of a number multiplied by an x, we divide the entire left side by x, not just part of it. The entire left side by 3. Not just part of it, but the number we're getting rid of, we multiply the entire thing by that number. And we also divide the entire other side by 3 as well, because 3 over 3 is 1. So that leaves me with 1x, or just 1, so we can get rid of that, or just x, so we can get rid of the 1. 12 divided by 3 is 4. So when I have 3x equals 12, we just found out that that x must be 4. So what happens when we have a fraction? Same thing. 1/2 is being multiplied by x. So in order to get rid of that 1/2, we divide this side by 1/2 and this side by 1/2. Now we don't have to do anything with this because any number over itself, no matter what, even if it's a fraction, is just 1. So we have 1x left over. And now I have 3 divided by 1/2. And this is why we learned how to divide fractions before. So it's 3 over 1 divided by 1/2. Now remember, the bottom number, if we turn it upside down and multiply it, that's the same as dividing it. Now I've got 3 over 1 times 2 over 1, which is 3 times 2 is 6, 1 times 1 is 1, so that equals 6. So x equals 6. Clear here. 1/2 of 6 is 3. Now this is where it doesn't really get complicated or confusing as much as just a little bit busy. If I have 1/3 x plus 2 equals 7. I've got a couple different things going on here. And again, I've got to get the x by itself. So I've got to get rid of the 1/3, and I also have to get rid of the 2. So I always get rid of my plus and minus numbers first. If I have a number added to the variable or subtracted from the variable, I need to do that first. Another way of doing it is I always say get rid of the things that are furthest away from the variable first. and then kind of move yourself toward the variable. So let's get rid of the plus 2. Well, if there's a plus 2, to get rid of it, we subtract 2. And that makes that go away. So that leaves me with 1/2 x. Nothing happened to that. 7 minus 2 is 5. Now I get rid of the next number that's close to the x. In this case, it's the 1/3. And it's being multiplied by x, so I divide both sides by 1/3. That makes that one go away. And I have x equals 5 over 1/3, or 5 over 1 over 1/3. And invert and multiply, so I multiply that by 3 over 1, and that goes away. So when you divide, remember, the bottom number you flip upside down and multiply. Alright, so that means we multiply 5 times 3 is 15. 1 times 1 is 1, or x equals 15. So this is example 3. Really nothing hard, it's just dealing with fractions instead of whole numbers. So we're going to look and we're going to say, oh, well, we have a number multiplied by an x, so let's get rid of it. So we're going to divide this side by -4/5, and we're going to divide this side by -4/5. And we know that this just goes away because we're dividing it over itself, which anything over itself is 1. 8/15. When we divide by a fraction, we invert, so we turn this upside down to positive 5/4, and we've got a negative there. It doesn't matter where the negative goes on the 5 or on the 4, it doesn't really matter, and we're going to multiply. Okay, so before we multiply, and this kind of goes back a little bit in some of the previous lessons, we're going to write the product of primes for each of the terms because it's obvious that there's some canceling that can be done. -5 is already prime, and then 2 times 2. Okay, so I can cancel this 2 with this 2, this 2 with this 2, and I can cancel this 5 with this 5. Now, one of the things that's important is we did not cancel the negative. It's still there. So we're just going to kind of tag that negative on. So all we have left is a 2 on top, and the negative, so we'll stick that negative on there, and a 3 on the bottom. So at this point, this is reduced because we reduced it before we multiplied through, and we're done. So example 4 says 4x equals -20. We're going to get rid of that 4 by dividing both sides by 4. That goes away, leaving us with x equals -20 over 4. So we can, you can either write this as the product of primes, and that cancels, leaving us with the negative sign and the 5. Or we can do 4 divided by 20, or 20 divided by 4 is 5. And so I know my answer is -5 there. That negative comes right there. Let's see, what else can I do? I can just know that 20 over 4 is 5, but make sure you reduce these. So this is example 6. This is as hard as it's going to get. And first of all, we combine our like terms. Anything that we can combine here, we do that before we do anything. So I can combine these two because they have the same variable and the same exponent. So 5x plus -8x. Signs are different. Take the difference between the two, put the sign of the biggest number on top or on the answer, and we'll leave the plus 3. Then we have 4 minus 10. Again, I'm going to change that to plus negative. Take the difference between the two, sign of the biggest number on there. So now we have -3x plus 3, didn't do anything to the left, equals -6. Alright, so again, we're still trying to get this x by itself. The number furthest away is a plus 3, so we're going to subtract 3 from both sides. And those go away, and that leaves me with -3x equals -6 minus 3, or plus -3. Signs are the same, so we add and put the sign on there. and negative 3x. At this point, we divide both sides by negative 3 because it's being multiplied by negative 3. Divide by negative 3. Those go away, and we have x equals negative 9 over negative 3. Now 3 goes into 9 3 times, and because I have two negatives, it's a positive 3. So x equals just 3. Okay, so that's it for the lecture on 3.3.